All right, here we go. Well, the introduction, thank you. I'm Vincent. I'm Vincent Ruijter. I work currently for OpenBook as a security engineer. We're trying to become like the new ethical social network. And I'm doing security engineering there, and I'm also basically the hacker in residence, do a little bit consulting here and there. And I'm also employed by KPN Cert as an incident response guy. And I love Vim, so I learned how to quit it, and it's like a really good text editor.
Hi, and I'm Valentine Mairet. So a little bit about KPN. This is the one of the biggest Dutch telecom companies, and I work for the red team. So he's blue, I'm red. I studied at TU Delft, which is also a university in the Netherlands. I did my master's in computer science, cybersecurity there. I'm also the organizer of WICA NL, which is the Women in Cybersecurity group of the Netherlands. And I'm a defender gone attacker. So my master's thesis was about network anomaly detection. And now I wanted to get away from machine learning as soon as possible and go into a red team. So that's what happened. But first, before we go into this talk, this was actually funny because one of the volunteers asked me how you exactly pronounce Kubernetes. So we wanted to get this straight with everyone in the audience. So how would you exactly pronounce this word? Like you can shout it.
Kubernetes.
Yes, so some people say Kubernetes, some people say Kubernetes, blah. This is actually the Greek inscriptions of how you would pronounce this word, because this word is from Greek. It actually means pilot, and I think it's pretty fitting that we are in an aviation center to have this talk. So it would be Kubernetes, I guess, and because Jess, she's a very famous Kubernetes hacker, developer, everything, and she says that we're going to take a swing at this and say Kubernetes. So let's go with this.
And for me, this will be the first talk where I say Kubernetes. So you probably hear me say Kubernetes sometimes, but yeah, it's a bit different.
So today we're going to talk to you about Kubernetes and introduce it first. What is Kubernetes? How did it come to be? Then we're going to go into attacking Kubernetes because there are some really cool exploits and cool hacks that you can do in order to attack it. And we're going to show a demo of this. And then we're going to talk about, okay, we attack, and then how do we log shit in our clusters so we can know what's going on? Yeah. So we're going to talk on how we combined multiple tools to create a logging architecture. And then we're going to show what these attacks look like in the logs. So attack traces in logs, and with some demos of what you see in the logs. And then we're going to talk about the alert system, which is the tool we developed in order to label logs. And we're going to present the Kubernetes Security Dashboard with some more demo time.
More. So what is Kubernetes? It's hard to pronounce, that's for sure. It's currently, it's a container orchestration tool. It's usually combined with Docker, but it also supports other container software. And it's written in Go and released, I think it's invented by Google in 2014. And it was, I think, donated to the Google, what was it again? To the Cloud Native Computing Foundation in 2016. And the #1 Git repo on Twitter right now, the Git repo on GitHub, is the Linux kernel. And Kubernetes repository is a close second. It's one of the most active repositories on GitHub. Kubernetes is around for quite some time. I first encountered it in, I think, 2015, somewhere on the internet. It had no authentication whatsoever. Basically, if you discovered the API, you got some nice error messages pointing you where to go, and all the actions you were doing on the API were basically admin actions. So you could spawn pods, scan networks, get to the local host. It was very easy to hack, I guess. It wasn't really hacking because it was a feature, right? No authentication. And since version 1.9, they started using role-based access control by default. So now you can make very nice YAML privilege settings and fine-tune it very nice, and you can make it actually really secure nowadays. And also, there was a nice tool which was good for managing your cluster. You could install a Kubernetes dashboard, you see that one again, inside your cluster, and then you could very easily administer the cluster, and could do some shells, spawn some pods, and do certain things. And all these things were by definition and by default done as cluster admin. And after numerous cases of abuse of this dashboard, they decided from version 1.7 onward to not allow by default all the actions to be Kubernetes admin. So now you need to log in with a certificate or with a JWT token. And also since version 1.7 and version 3 of etcd, etcd is the secret management interface of Kubernetes, it supports encryption. And before that, everything was stored in plain text. So if you managed to cut the database or run strings, you could basically see all the private keys and all the JWT tokens. But now they are supporting encryption. So it's really going well nowadays.
So before we go on with a lot of terminology that may be strange to people who do not have any experience with Kubernetes, we're going to give you some simple definitions of the terminology we're going to use in this talk. So when we talk about a node, we talk about a worker machine inside a Kubernetes instance. And you have the master node, which manages the Kubernetes API. That's how all the nodes talk to each other and basically manage each other. Then you have secrets, which were mentioned before. These are all the authentication tokens, credentials, certificates, keys inside super secret files. And then you have namespace, which is an abstraction on top of Kubernetes instances to support multiple virtual clusters. Then you have a pod, which is a set of multiple containers, a container that I think is fine. The kubelet, which is an agent that runs on nodes and makes sure that containers are running inside pods. And kubectl is a command line tool interface to communicate with the Kubernetes API from the master node. And then you have a daemon set, which is a daemon set that ensures a copy of a pod is running across a set of nodes inside a cluster. And
kubectl, some people pronounce it kubectl. Other people pronounce it kubecontrol. And it's a very good post-exploitation tool. If you find out you're running on a Kubernetes instance, you can basically download a statically compiled kubecontrol binary and start interacting with the cluster. It's a really fun thing. Yep. And a daemon set is also great for post-exploitation. But I'll explain a bit more about that later.
So this is a simple graph of what a typical Kubernetes instance would look like, where you have 3 nodes with one master node. And yeah, I'm going to use the mouse. These nodes have a pod containing multiple containers, in this case 4. And containers can be a web server, database, a bit of everything. And they communicate directly with the master node through the Kubernetes API. So why are we here, we may ask. So we're here to present this monitoring tool we built. In order to build this, we had to configure a logging architecture for Kubernetes to store audit logs. So basically, how do we gather all the logs generated by Kubernetes and visualize them properly and sort them properly? And then we perform analysis on these logs to detect and label certain events that we think may be interesting for the detection of actual attacks on Kubernetes clusters. And then with this, we created the security dashboard, which provides visibility over your clusters and some explanation about what is going on inside your Kubernetes instance. And why we did this is because we couldn't find, especially when we were hacking Kubernetes and everything, we wanted to see, okay, how can we detect this? Well, there was no really explicit resource on how to monitor Kubernetes, so to have visibility over your clusters. And there were no tools online, at least, to label activity. So basically, you see some logs, and how can you make sense of these logs?
Definitely no open source tools.
Yeah. Yeah. And then there was no security dashboard like this, where you can visualize everything nicely.
So now we show some topics or some points on how you can actually attack Kubernetes. A very common one, and one we will demonstrate, and also a very simple one, is trying to create a pod in privilege mode. When you create a pod in privilege mode, you basically give the pod access to the character and block devices of the node, which is actually a machine or a virtual machine running the Kubernetes node. And if you're running as root in the pod, and you are in privilege mode, you can actually mount the hard disk into your pod of the host file system. And that, yeah, you could just change cron jobs, add your public key in there, and it would basically be catastrophic. And if you would then add that to a daemon set, and a daemon set allows you to run a pod on all the nodes in the network, and they all allow you to create privileged containers. And you can even add commands in there, like, hey, give me the shadow file, or add the public key to everyone, or make a cron job so that all of the nodes connect back to me. You basically have a lot of root shells depending on the size of the cluster. Another way is to create a pod with a host path. It's basically a mount option. You could, for instance, say mount the root file system of the host in my root folder, which is a nice folder to do so. And then you have the same access if you are root in the pod. Another one would be to abuse privileged pods. A very well-known example is by trying to log into the dashboard, or maybe you find a command injection from a pod that is running as privileged, and you can still abuse tokens, just like with OAuth and other things. And there are some default tier exploitations that might be vulnerable, and there's of course many custom implementations of certain container and pods that might also be vulnerable. It might be an endless list because continuously people find new ways of compromising pods.
What's also really interesting with attacking Kubernetes is also because on the web currently you have a lot of Kubernetes instances that are still outdated, where they don't have access control, where you can just access the dashboard like this, just by logging in. And so this is a really good way to basically attack China or something.
You can find them on Shodan, and in China there are actually quite a few insecure clusters, but I didn't tell you that. This is an example of very simple, it's a YAML file, and it basically says, I'm creating a pod, and the metadata is the name of the pod, which in this case is a host escape, because we are trying to spawn an Nginx container with the privileged mode enabled. Spawning an Nginx container is because, pods are basically expendable. When they finish their duty, they die. And when the new job is available, they spawn again. And an Nginx container continues serving. And because I'm lazy, I rather spawn an Nginx container so I can immediately access the pod and get the file system. And when privilege mode is enabled, then you can, of course, add the block device. And this is another example where you basically also create a pod, but then instead of doing privilege mode, you actually create you create a volume called host root, and that's the / that's basically the root file system of the node, and then you add that to a folder on your pod. And then if you run this and you're allowed to use the host pad, because you can restrict that nowadays, you also can get a root shell on the node, which is quite nice. And as I said before, attaching this to a daemon set means pwning all the nodes. Now we will show a sample attack, with basically an ASCII of one of the privileged pod attack. The first step, what I'll do when I log in or when I find my way into a cluster, is doing some reconnaissance. Secrets are usually mounted in Kubernetes by default in pods. So if you hack a machine and you go to var/secrets and you see a Kubernetes folder there, that might mean that you are actually inside a Kubernetes pod. And if you have that file, you can try to install or download the kubectl binary and start interacting with the cluster. And that's what we are doing here. We'll do some reconnaissance. We're spawning a privileged pod. We'll be interacting with the privileged pod, and then we'll show you the file system of the actual node.
So let's go.
Can you guys see this, guys and gals? Okay.
Yes, my laptop is called Storm Pooper.
Yeah, that's the best name. So here we are going inside an actual cluster. We'll first use the exec command to interact with the pod, a victim pod in this case, and you can see that we basically have access to all the namespaces. So as you can see here, we can list some pods in the default namespace, kube system, and countries. We can also list some services, which are basically exposed endpoints that can be on the network side. There's a Kubernetes dashboard there. There's a vulnerable pod, and also the default Kubernetes. And over here, we create the YAML file with privilege mode enabled, and then we will try to actually create this pod. And if that works, then you're basically already 90% into compromising at least the node. And there you go, unsafe space. It's been added. We spawn an interactive shell. We're running as root. And now if we mount the block device, we're actually on the root file system of the node running as root. And there will be dev SDA1 somewhere in here. We can verify that we are actually, because we have some mounts, of course, from the host on dev SDA1. So we try to mount dev SDA1 into the mount directory, and then you can actually see, well, this looks like a root file system to me. And then you can cut the passwd file. And you see there's a Donald Trump user there available. And you can basically. It's not
real, by the way.
It's not real, no, unfortunately. Next one. Oh, this is me as well. Oh, snap. Yeah, so now we'll talk a bit about the logging architecture. What did we have to do to configure Kubernetes to send its logs to our Elasticsearch cluster? Well, it's a lot of YAML. This is the API server YAML file, which is actually found somewhere on the cluster. You basically have to add audit policy. We have an example, strict audit policy in our Git repository, and you need to specify a location where you send the audit logs. And then there are two options for the audit log format. You have a JSON format and a legacy format. The legacy contains some information, but the JSON format contains a lot of verbose information, lots of resources. You can actually recreate entire YAML files from the JSON output. And yeah, it's really verbose. I will be telling that a couple times more. This is an example of creating a host path. You can actually see from the specification that I'm trying to mount host path root on the root of the node. And yeah, as stated, it's very verbose. You can easily find out exactly what configuration for a pod an attacker has pushed into your cluster. And yeah, once we have to set that up, we needed to do some customizations. We have to install FluentD. FluentD is quite easy to use. It basically is a daemon set that runs on all of the nodes and reads the var log on the node, so you need to give it access to var log. It grabs the Kubernetes logs and throws it into Elasticsearch. But there were some problems with Elasticsearch static mapping in this case. So we had to add some random because what Elasticsearch doesn't like duplicate messages. And if you have multiple nodes in your cluster, then you might get duplicate messages in your logs. So in that case, you need to add some random by doing some hashing. And therefore, we needed to create an init container, which is basically a container that compiles modules or installs packages before you actually start your container. In that case, you don't have any artifacts like compilers running inside your pod. And yeah, we use Elasticsearch because it's good with varied data sets. And of course, because there's a Kibana dashboard that's very easy to use and allows us to easily query the database. And yeah, as I said, there were some problems. The static mapping of Elasticsearch, yeah, it's basically like self-learning, I guess, because you send it one JSON file and it automatically creates a mapping with the object it expects. But then if you get a different Kubernetes message, which might not contain a certain key or contains an additional key, the Elasticsearch is going to reject your message. And you're basically going to end up with a very empty Elasticsearch cluster. So yeah, we have to serialize some components that might be different than the regular log message. And yeah, when you work with multiple nodes, there was an entire Git issue on that, where they had random issues, and the issues were basically the mapping was not correct, or you had a duplicate entry. So yeah, we found out that we had to compile some modules. And we have the entire init container and all of the steps for compiling it. They are already in one big YAML file, so you basically just have to install it, and the hard work is basically done.
So if you're familiar with the LStack, Elasticsearch, Logstash, and Kibana, Fluent is actually the Logstash, basically the Logstash for Kubernetes.
Oh yeah.
So if we have our Kubernetes instance here, Fluent basically runs in a container inside a pod, inside a node. It has access to varlog on the file system, and it pushes directly logs into Elasticsearch, which you can visualize in Kibana. And this would be an example of what the logs would look like inside the Kibana log overview, where you have timestamp, user, request URI to the Kubernetes API, the user agent, and the Kubernetes method that was used, just like HTTP methods, but then for Kubernetes.
And now we show some attack traces. They don't have to be attack traces, but they are suspicious traces at least, because of course normal administrators also run commands in the cluster. This is an example of API usage on the cluster. As you can see here, this is basically default. This is a preliminary request that basically gets the API specification of the cluster before doing any requests. And over here you can see that we're trying to get all the pods. We're trying to get information from the pod host escape in the namespace default, and it's basically done by the exec-only service account. And over here, we're trying to create a new pod, and this will actually contain the specification of the pod you're trying to create. And over here, you have you're listing all the pods in the namespace default with a limit of 500, and you can see here is done using, I think, kubectl. And yeah, you can actually see the host name of the username there. This is an example of getting secrets. The first command says, give me all the secrets in the cluster, limit it with 500. This is usually not allowed if you're in a namespace and you have restricted access. This is basically the same thing. There's 2 list requests. And over here, you're trying to get the secrets from the namespace default. And over here, yeah, it's the same thing. You basically list all the secrets. When you see these things in namespaces like kube system, it might be a little bit suspicious. And over here is an example of a kubectl exec command. Kubectl exec is used to send commands and interact with pods. And you can very clearly see, yeah, the Kubernetes admin did this. It's trying to access a pod in the namespace kube system, and it sends the command binls. And you can see like this, the user TTY. You can see single commands being sent to a pod, but you cannot see interactive shell commands being sent to a pod. Because when you start a bash shell with interactive mode, it basically negotiates a WebSocket connection, and then all the data will be sent in that connection. And there's currently no way we know where we can actually log all the commands that are being sent over that connection. And this is an example of a dashboard we made where you can actually see that a privileged container has been spawned. In this case, if someone spawns a host escape pod in your network, you're basically screwed. So you need to have a look at your cluster. It's a good indication of a compromise if you don't allow users to spawn privileged pods by default.
So now we're going to show you a demo. It's not really a demo. It's just a overview of all these logs in Kibana. So we're going to show these attack traces of the kubectl, kubectl API usage, the secrets, and the command execution. So bear with me. There it is.
Wow.
So these are, is it readable? I think so.
Yeah, I think so.
So there are all the logs that we have generated ourselves from a Kubernetes instance. And you can see the request URI here, exactly like we showed you in the slides. This is a enumeration. Yeah, this is basically someone trying to get information about the etcd Kubernetes pod. Here, it's someone trying to get information about all the pods inside the namespace kube system. And to see, you can see all these logs here with timestamp, username, user agent, method. Then if you want to look for secrets, I'm just gonna hack it in there. So this would be the typical request URI of secrets retrievals. So you have the limit 500 here. This goes automatically, by the way. It automatically will display maximum 500 entries. And then to see the command execution. Yep. Yes, there they are. So you see someone open bash. This is pretty explanatory in itself because it says in which container bash was open, and it's the nginx container that he spawned. Bash here, and then you basically see ls here, and we have some fun one like I'm an evil Bulgarian who likes maple syrup because we have a Bulgarian colleague. So
who likes maple syrup?
Who likes maple syrup? So that's why. So this is pretty interesting because these requests are pretty consistent with the activity that happens inside the cluster. So if I run a command inside a pod, it's always going to look like this. So this is very interesting if we want to do detection, basically, or at least labeling these events that happen inside the cluster. And this is a nice bridge to this one. So the alert system. So we called it alert system because eventually we want to do this whole IDS of Kubernetes idea. But for now, it's detecting events inside the Kubernetes logs and labeling certain activity inside your clusters. And this is where Kscope comes into play. So we called it Kscope, and we made a nice logo out of it. I don't know about copyrights, but whatever. And it's a helper for Kubernetes security monitoring. So we basically analyze these logs and label events and say, OK, this was someone doing enumeration, this was command execution, this was creation of a privileged pod, and all this. So Kscope, actually the goal of Kscope is to make the analysis of Kubernetes audit logs easier. So when you are a developer and you want to know what happens in my cluster, you run Kscope, and then you see, oh, here someone tried to get information from the pods. Oh, someone executed this command, and all that stuff. And it classifies logs into these labeled events using regex, because we have this consistency across all the request URIs that you see. And basically, we can say, OK, this is command execution. You're 100% sure that it is, because it says so in the request URI. And what it does is provides more clarity about the event. So it also tells you, yeah, this is the date, this is the user, this is on which the pod where it was executed, this is the container, all of this, and it will also give you what type of alert it is. So if it's an enumeration, command execution, tampering with the cluster, so creating and deleting pods, and the last one was secrets. So Kscope can do two things. It can perform the analysis on static date ranges. So you can tell it, okay, analyze everything of last year. This is going to take a really long time if you have terabytes of logs, but that's your fault, I guess, to have terabytes of logs. And it can also perform analysis on streaming data, and almost real time, because it needs to wait for the logs to actually get into Elasticsearch, and we've noticed a certain delay of 2 seconds, which is not that bad. And then it basically waits till all the logs come in, and then it performs the analysis. And it's written in Python. Kubernetes stuff are all written in Go, so maybe we want to switch to Go at some point, but we're basically hackers, and we like Python, that's why. So it uses the Python Elasticsearch client, and we multi-threaded it for extra speed. So this is what it simply looks like in a flow diagram. So it fetches the logs from Elasticsearch, parses the logs, and then pushes them back as alerts into Elasticsearch. So where does it fit into the big picture of our Kubernetes instance? Well, it's actually outside of Kubernetes. It's directly connected and directly communicates with Elasticsearch back and forth. And you could actually integrate it inside a Kubernetes cluster, but for now we kept it outside. And this is a typical example of what it would look like in the logs, all the alerts that were created. So we have like this labeling, so this is pod enumeration, attempt to get all secrets, information request, that's when someone runs describe inside the kube control, and the command execution. And it tells you the username, the main namespace, the pod, and it actually also tells you which container when you have the command execution, and it tells you a little bit more. It also points back to the log entry in the original Kubernetes logs that made it confirm that it was this alert. So Kscope has a few limitations, actually, because you can imagine that since we just map with regular expressions, it's a one-to-one mapping. So this log means command execution, or this log means someone tried to enumerate a pod. In this case, it cannot yet correlate multiple events. So what would be nice is that we would be able to follow an attacker doing a bunch of things. So like it gets into the cluster, it enumerates all the pods, then it creates a pod and all of this. It would be nice to be able to correlate everything and make it into one concrete attack.
You could even get your access logs from your Apache or Nginx containers. You can even throw them also in your Elasticsearch, so then you can really correlate from the first hit, compromise, all the way to your cluster. So you can go really far with that aspect.
Yeah, and one more thing is that the rules that we have, so the regex detection is inside the code. And it would, like, when we want to add more detection, we have to actually edit the code. But these limitations are actually potential for future work. And this is our to-do list for in the next years. We want to create an interface for adding new rules. So if not having to code the new rules, basically, and be able to remove rules easily. And this correlation of multiple events to detect more complex attack traces. So indeed, follow an attacker through his entire attack course, and basically be able to also do some time correlation there for more complex attacks. And then we would like to integrate triggers. Like, for example, if you have a developer managing your Kubernetes instance, if there's a grave attack detected inside your cluster, it would be nice that this person gets an SMS or an email or something. And then, ideally, we would like to connect the alert system to Kubernetes, because if you detect a malicious IP inside your cluster, it would be nice that Kubernetes says, OK, this IP is blocked, no more access. So like a real IDS, IPS. And now we go into the Kubernetes Security Dashboard. So we're going to demo the dashboard itself, show what it looks like. It's in Kibana, so we didn't make the UI, but Kibana is awesome for this. It shows you the logs, the overview of the alerts that were created, some nice pie charts, the kubectl commands, because since we are able to, since the request URI is very consistent, we're able to basically reverse which kubectl command was executed, for example, to do pod enumeration, or to retrieve secrets, or spawn privileged pods. And then we're going to show you an attack another attack on Kubernetes, and how this attack is detected inside the dashboard. So we don't have to pray to the demo gods because we have videos, so that's nice. Yeah. So this is the dashboard, how we made it. Because it's Kibana, it's very extensible and flexible. You can even create your own pie charts. So here we have an overview, again, of all the requests that I showed you earlier, just to remind you of the real logs. And then this is a basic pie chart to show what type of alerts were detected this year, in this case. So we have enumeration, command execution, tempering, that's creating and removing pods, and retrieving secrets inside the cluster. User activity, so what type of users of the Kubernetes cluster were active. So Kubernetes admin is very active. This one is a bit less active, and then this one is totally not there. And then you have a list of alerts. So command execution detected, pod enumeration, command execution again. Yeah, all of these. And then it actually also tells you which command were executed. So here you have bin bash, ls, so all this. And this is the reversing of the kubectl command. So this is a kubectl command to get all the pods in all namespaces, like this. And then this describe is to get more information about a pod. Get pods is to list all the pods, all of this. Secrets retrieval, attempts to get secrets, response 200, which means it was OK. And then unauthorized requests. So this is a list of all the requests that were unauthorized by the Kubernetes API. And the privilege mode spawning. So this pod was spawned in privileged mode. This is basically what it says. So this is the dashboard. Many more things can be added. So now we're going to show you the attack. Folders.
The video, yeah. So yeah, we're going back to the cluster again. We're trying to enumerate some pods. I'm trying to enumerate all pods in a cluster namespace. So a cluster scope is not allowed. So you should see that show up in the forbidden actions. Now we're trying to list, I think, all the namespaces at the cluster scope, which this account is also not allowed to do, not even at its own scope. And now we're opening Vim, of course, to have a look at the pod policy, and we're trying to spawn a privileged container, I think, and a host pad. Of course, an Nginx, and with the name host escape, because it's very obvious what's going on here. So we're trying to spawn the pod again. A bit of a typing issue there. Escape host pad.
You managed to quit Vim.
I managed to quit Vim, very important, yes. And then we wait a while because it takes some time to create a pod, at least in our cluster. And now we run the kube control command to see if the pod's active, and it's there, the host escape one, all together with the busybox one. And now we're of course trying to get an interactive shell and see if we can interact with the pod again. So opening bash, and you see we run as root because it's the nice hashtag. And then we go to the root folder, and there's a root file system, which is very nice. There's a passwd file, and then there will be a shadow file containing the credentials. Just so you know that we're running as root on the pod, we have privilege mode enabled, and we're running on root of the host file system as well. So now let's have a look at the dashboard.
Yeah. So this is the dashboard again. So the first thing he did was trying to get the information inside the namespace. So it takes a bit of, here. Get pod namespace default, it was unauthorized. So it takes a bit of time before the next one shows up here. So because he did it twice. So he tried to enumerate all pods in default, and that didn't work out either. And now he created a privileged pod. So this should appear here. And there should be a tempering alert popping on the pie chart as well, because this pod was created. Takes a bit. There you go. And then we had the command execution. Waiting. I did get pods again to see if this pod was running. So that's why it appeared here. No, here, sorry. And there you go. Yeah, the command execution that was detected. And it also said which command here, bash. Then you cannot follow anymore because we cannot see interactive shells yet.
Unfortunately.
So we're concluding this. So Kubernetes is a great tool. It's cool for hacks. A lot of instances on the internet are still vulnerable for a lot of things. And it offers a lot of opportunities also for blue teaming, so detection and protection. So that's why we basically created this Kubernetes Security Dashboard by combining all these tools. So Fluent, Elasticsearch, Kibana, and our own Kscope tool for the labeling of events. And this dashboard's purpose is to provide visibility over the Kubernetes cluster activity. So you can know exactly what's going on inside your clusters and have explicit information about what's happening.
And for future work, well, there's a new way of logging nowadays in the Kubernetes, new audit logging method in Kubernetes version 1.13 and onwards. I haven't had the chance to play with it yet, but it looks promising and has more, I think, detailed audit logs or more fine-tunable audit logs. And of course, we can continue to work on KDCOP. For instance, if we decide to rewrite a module in Go, we could, for instance, implement existing Kubernetes kube control commands. You can basically import the library and try to, let's say, if someone is tampering with your cluster, you can automatically revoke privileges. You could automatically delete pods, and that's actually where you would like to go with KDCOP. And that's sort of things you are looking into.
So thank you for listening to us. We have here the link to our GitHub repository because it's actually open source now. We've been busy lately, so we've not contributed too much on it, but we really want to make this tool better than it is now. But at least we also provide everything, like how you should set up Fluent, how you plug it into Elasticsearch, and all of this, and how you install Kscope. So this was us, and thank you for listening.
Yeah.